As long as we can add and subtract, life is good. If we didn't watch the podcast, we might be a little wrong for that. Are we okay? Please. All right. So, we're going to solve the following. Our goal in order to solve, guys, is first off, we have to have an equal sign. That's how we know we're solving. Okay? Cool, cool, cool. And it says 3 over x plus 3 equals 6. 6 is over what? 1. Perfect. Okay? Good, good, good. Cool, cool, cool. If we can get a fraction equals a fraction, then we can solve. So, cool thing is, we're starting off as fractions equal fractions. So this is great. If we don't have a fraction equals a fraction, we have to make a fraction equals a fraction. And how do we do that? By adding and subtracting. That's why we need to know adding and subtracting. If we have a fraction equals a fraction, we can cross multiply. The moment we cross multiply, though, we're going to get rid of our denominators. So what must we do first? MPVs. Slap my hand, we're like, girl, I got to say MPVs, because when I go to cross multiply, my denominator's gone, and then cheers. Okay, so what did I just say? MPVs. What are our MPVs going to be based off of? Our denominator. The only time they're not off our denominator is division. They're still off our denominator, but things move to the denominator, remember? So we have that extra one. Okay, so we have x plus 3 can't equal 0. Move my 3 over. X can't equal negative 3. Now this is the thing. When you read the word solve, everyone see that? We see solve? It's important. It's très important en français. We're going to box that baby. And what that means, every time we see solve, it don't matter what math course we're in. Okay? It doesn't matter. What it means is, tell me what the heck the variable equals. What's the variable in this one? What letter is it? X. So ultimately, I'm trying to get x equals some sort of number and then box it. That's what solve means. So when people just give me stuff and never give me what the variable equals, I'm like, you didn't solve, you did some other things. So when it says solve, it doesn't matter what unit we're in, we have to get variable equals number. We agree? Okay. So we have our restrictions. X can't equal negative 3. What happens if our answer is x equals negative 3? Well, it can't be that, right? So we circle it, put a line through it, we say extraneous. We've done this before. We've done this in grade 11 before. So when you solve, you have to check to make sure that that whatever answer you get actually can happen, right? And we know x can't equal negative 3. So if we solve it out and we get x equals negative 3, we're like, no, no, no. That would make my denominator equal to 0, which is not allowed in mathematics. So not going to happen. When we circle it, put a line through it, we say extraneous. So that's why the MPVs are so important, especially in solving, because we're going to check our answer isn't that. Okay? So let's cross multiply. It don't matter which ones we pick first, but we're going to pick ones across from each other. So x plus 3 times 6, which I prefer to write as 6 times x plus 3, because I like distributing a monomial into a binomial, but if you do it the other way, it don't matter, right? So that's this one times this one. It's called cross multiplying for a reason. What goes in the middle? An equal sign. And the other cross, right? And you can only cross multiply when there's an equal sign. You cross multiply across an equal sign. Yes? So some people try and do multiplication across and cross multiply. If there's a multiplication dot, what do? Top times top, bottom times bottom, correct? You cross multiply across an equal sign. That's what you do. So we get 6 times x plus 3, and then 3 times 1. And we got rid of our denominator, correct? So that's why we had to state MPVs first, because our denominator is now gone to Alfonso. So what we're going to do, we're going to distribute 6x plus 18 equals 3. Now we're in junior high. I'm not even joking. This is junior high right now. How do I solve this? When we're trying to isolate a variable, so get a variable by itself, we do reverse BEDMAS. So we have to deal with the additions and subtractions first, correct? So right now this plus 18 needs to get out of my life because the 6 is being multiplied by the x and I can't deal with that first. I have to do reverse BEDMAS when I'm solving. So how do I get rid of a plus 18? Subtract 18. So we get 6x equals negative 15. Now what do? Divide by 6. Now remember, we could put that in our calculator and math enter it, and it'll reduce it for us, right? We know that. Or we can say, hey, it can take a 2 out of each. No, we can't. That's a lie. It can take a 3 out of each. And we'd be left with negative 5 over 2. But you can just type it in, right? It will give you a reduced fraction when you math enter it. We agree? Now, what do I need to follow behind with always? Doesn't matter if I'm simplifying or solving. The restrictions, man, PVs. So I say x can't equal negative 3. And I'm happy. Why am I happy? Because my answer isn't negative 3, correct? My answer is negative 5 over 2. So now I box it and just send it and say, yeah, I hope it's right. You never send a solving question. You never send it and hope it's right. Solving is the best thing ever because it doesn't matter what curriculum we're in. If I'm solving, I can check my solving. When I plug it back into the original, left side should equal right side. We agree? Okay. Now, what if I put x equals negative 2.5 instead? Am I wrong? No. I am not wrong if the answer is a terminating decimal. If your answer is a terminating decimal, then negative 2.5 and negative 5 over 2 actually get you the same answer. Everyone paying attention? Negative 2.5 and negative 5 over 2 get you the same answer. Okay. So, negative 2.5 and negative 5 over 2, if I fill them back in, are the same thing, yes? What if the answer was 1.333333 and I wrote 1.3? Would Mrs. Lepp be happy with me? No, she'd be like, girl, I ain't same answer. She would say, she'd be like that. Unless they told you to round to the nearest tenths, then go ahead. Right? Totally fine. Okay, we want to check these. We don't want to ever send it. Solving is the best because you should either be done the question and be happy or be done the question and feel like crying because you either know what's right or you know what's wrong. There's no in between. Yeah? Hopefully it's happy and not crying. But, you know, if it's sad, you go back, try again. Okay? So we're going to check it always. We aren't sending it. No. We're going to check it. How do we check it? We check it back into our original. So we get 3 over negative 2.5 plus 3 equals 6. And when you check anything, what's on the left stays on the left, what's on the right stays on the right. And you hope the left equals the right. And when it does, you cheer. Or when it doesn't, you're sad. Those are the only two options you have. So I have 3 divided by 0.5 equals 6. And some people might be like, that's not 6. It actually is. You can just type it into your calculator. It'll tell you it's 6 and you can believe it. Or you can go 3 divided by 0.5 is 3 divided by a half. We agree? And when you multiply, what do? Or divide? You flip and multiply, right? So that's why you get 6. That's why your calculator tells you it's 6, because it is 6. Does the person who is checking this need to know that you mathematically did it, or are they happy if that happens? They're happy if that happens, yeah? So, now do I walk away happy or sad? Happy. If I just send it, do I know what to do? Do I know what to be happy or sad? No, I'm just like, oh, it's right. Or maybe you're one of those people who's just always happy. And you're like, it's going to be good. But check it. Okay, I want you guys to try B. Can I just cross multiply? Do I have a fraction equals a fraction? Yes. Before I cross multiply, what must I do? NPVs, because when I cross multiply, what goes away? The denominator. And I must say NPVs before the denominators go away. Try that one out. Everyone's paying attention. I lose people when there's a variable on one side and a variable on the other. Life just falls apart. Mathematics is stupid. Like, that's where your head goes. Okay? And yeah. And you're like, yeah, girl, it's exactly what I think. Okay. So we are going to have a tactic to deal with it. How do I know that people struggle with that? Because I've been teaching for 18 years. That's how I know you start. I know exactly where you're going to make oopsies. I know that when there's a variable on one side and a variable on the other, you're going to just want to quit because you're going to be like, I don't know what I'm supposed to do next. I know that's what's going to happen when I give it to you at first. So you struggle a little. And then we go through and we just come up with our tactics and you'll be fine. Okay? But I know that's where a struggle is going to happen. It's going to have to happen. The other struggle that I think is going to happen in this question is the NPV for 4x plus 7 will be wrong. People will give me, like, wrong. So let's make sure that we can do that. So the moment I know that I put a number in front of a variable on an NPV, I know that I'm losing half the people. Okay? I don't want to lose half the people. I want to get all the people. I want you all to get that and be easy. So what do we do when it's NPVs? We take that x plus 3, and we say it can't equal 0. And we say 4x plus 7 can't equal 0. And then we're using junior high mathematics to get x by itself. Every single time, it is not changing, it's nothing crazy, I'm not making up anything new. Okay? So for this one, we subtract 3, and most people can get this one right. Most of the time, this is a non-issue. However, I know the moment I put a 4x plus 7 up there, things are going to go a little crazy. Okay? Remember, you're just doing your junior high math. Don't overthink things. Sometimes you guys overthink it. So here, we're going to have to, once again, you get x by itself. When we get x by itself, we do reverse bed maths. So the first thing we need to deal with is the additions and subtractions. I can't deal with that 4 until that 7 is gone. Right? How do I move a plus 7? I subtract 7. So I get 4x equals, can't equal, negative 7. And now I can deal with the 4 because I can deal with multiplication and division after I've dealt with addition and subtraction when we're trying to isolate a variable. Okay? So we're going to divide by 4. And we're going to get x can't equal negative 7 over 4. Okay? After tomorrow, we are done rationals. What I don't want to come out of your mouths or can enter your brain is, I hate rationals, I can't do rationals. Because if you enter the room with that in your head, you will not be able to do rationals, and you will hate rationals, and you'll immediately find it harder. Okay? We have until Wednesday to get it done really, really well, right? Next Wednesday, not this Wednesday. So you need to release, and I know some of you are doing this, I know you are a lot, because this is not the first rodeo with this unit in 30-2. People are going, I can't rational, I can't do these, this is the worst unit ever. I can't wait till it's over and I get a new one. Okay? They don't go away. And like a quarter of the diploma is the rational unit. It's a big part of the diploma. They make a larger portion of it. So we're not going to let it go. We're not going to release it. Yes. We have to deal with it. So we might as well change our mindset and say, I can do this. I have until next Wednesday. That's a whole other week and a half, right? I can do this. I can do this. Believe in myself. If you're coming in with the whole negative impact of rationals, it ain't going to go pretty. Okay? So we're going to change our mindset if we're one of those people with the mindset, which I would say is probably 60% of you. Would be my random guess. Maybe 70. Okay? I know people don't like this unit. But by the time the test comes, people can do this unit and they've changed their tune unless they're really set in their ways. So we're going to change our mindset and say, we can do this. I can do this. Okay? All right. So we cross multiply. We get 3 times 4x plus 7 equals 9 times x plus 3. Now, answering my question, does it matter if I would have done them the other way? Does it matter if I would have put 9x plus 3 first? No, right? It just matters what's crosses on one side, what's crosses on the other side. Doesn't matter which side. So then I distribute, because that's what I have to do. So I get 12x plus 21 equals 9x plus 27. And then people get stuck.
Do you have to write like 3 going into 4x plus 7, or can you just do it right away?
I would write it, because if you oopsie, can they give you anything? So like if you did 3 times 9 is 21, let's say, and you didn't show that first step, could you, if that happened, could you get any marks? No. So would it be better to show that step, and then if you maybe put 21 and 27 instead of 27, you could get some marks maybe? Yeah, that's why I would. Yeah. All right. So now we have an x on one side and an x on the other, and a number on one side and a number on the other, right? We need to get our x's to be together. We need to get our numbers to be together. Doesn't matter which side I pick to do which. No. Okay. So if you're spending, now everyone paying attention to me, everyone looking into my soul, if you're spending more than 3 seconds deciding which x to move to which side, you have spent more of your life that you're not getting back. That's what you've done. Pick an x and move it. Like, I'm moving the 12. Like, that is what, if you are spending more than 3 seconds, like, should I move the 9 or should I move the 12? The 12 or the 9 or the 9 and the 12? I don't know, I'm so confused. Pick one, move it.
Do you just do like the bigger number then?
So I often will do the one that will make it positive. So I spend like 1 second, and because I can do it faster, and I'm like, if I move the 9 over, I'm going to get a positive 3. So I often do that. But it doesn't matter. So I'm going to be a rebel and do what I normally wouldn't do. I'll move the 12 because it literally doesn't matter. So I'm going to, how do I move a positive 12? Negative 12. So I'm going to move this bad boy over with the x's. So So when you get stuck, when there's an X on one side and an X on the other, be like, girl, I gotta put the X's together. Like that's just where your head goes. You know? Just move the X's. So, could you move the number 2 and move it all in one step? Sure. If your brain can do that, you go ahead. If you're like, girl, that's too much for me, then don't. And I'm gonna do the 2 steps. So I get 21 equals 9. Remember, when we're adding and subtracting, these babies are xylophones, or xiphoid processes, or x-rays, whatever you want them to be, but make them be something so that you don't square them. So I have 9 xylophones minus 12 xylophones is negative 3 xylophones plus 27. Now am I just back to grade 7? Am I back to what we did in the previous one? I have one variable, 2 numbers, move the numbers to the other side, right? So where do you get stuck when there's a variable on one side and a variable on the other? So what do? Just make that go away. Put them together, and then that problem's gone. So the people who can see an X on both sides, just put them together, life is good, because now we're back to what you could do over here. That was fine. It's just when there's an X on both sides that you guys get flustered. So make there not be. Move one of them. And don't spend more than a second. Just take one, add it or subtract it over, depending on what the opposite is. Right? Okay. So I need to move this 27 first. I'm going to subtract 27 to move it over. And I get 21 minus 27, which is negative 6, equals negative 3x. And now I can do the multiplication movement. Now what's the opposite of multiplication? Division. So I'm going to divide. And I'm going to get x equals 2. Now, oops, I forgot my MPV. X equals 2, x can't equal negative 3 and negative 7 over 4, which is awesome because that is not my answer. I box it and I send it and hope for the best. Do I do that? You got to check it, girl. You got to be like, I got this right or I cry. These are the options, right? So we're going to check it. So we're checking x equals 2. So we just plug it in. Left side, right side, right side. So I get 3 over 2 plus 3 equals 9 over 4 times 2 plus 7. So I'm going to get 3 over 5 equals 9 over 15. Take out a 3, I get a 3. Take out a 3, I get a 5. I feel like I should sing that song. Happiness is true because I really need to learn some lyrics. I meow when I don't know lyrics. Like yeah. Yeah. All right. C. Tears happen. They're like, there is not a fraction equals a fraction. What garbage is this? Lepp, you suck. I had just got that, and now don't like you. That's what you're all thinking. But you still like me. You just don't know it yet. All right. Is there a way that I could quickly move something and get a fraction equals a fraction? Anyone? Bueller?
Could you
Bueller?
plus the fraction to the percent?
Yes. You just add this bad boy over. Watch. It's like magic. And then you're back to happiness. And you know what? When everyone pays attention, they're so smart. Right? You know what I'm saying? Yeah, genius level. All right, so we have 2x over x plus 2 equals 5 over x plus 3. What do we have now, my friends? Fraction equals a fraction. Girl, this is so much easier. What do we have to do first before we do that? MPVs, yes. Okay, you try it out. This one's going to get you a quadratic, which is really going to make your heart sing. Try it out. Try it out. So, our MPVs are x can't equal negative 2 and negative 3. Say our MPVs, now we cross multiply. So we get 2x bracket x plus 3 equals 5 bracket x plus 2. And then we distribute and get a little like worried because we get some squares. It's fine though. This is where the fun happens. 2x times x is 2x squared. 2x times 3 is 6x equals 5x plus 10. Okay, there are 3 scenarios after we've cross multiplied that could come out of this, right? First scenario, I have an x, I have some numbers, I just do some math, like it's good, junior high, right? Second scenario, we did in the second one. I have an x on one side and I have an x on the other, get those x's together, yes? Third scenario, I have an x squared. Doesn't matter what math course you were in last year, you did this. When you have an x squared, what do you have to do? Get everything to? Yes, you get there. Everything on one side set equal to 0. So we are going to actually, whenever we have an x squared, we have to set equal to 0. So we are going to subtract the 5x and subtract the 10, so that it's going to be equal to 0. 5x and subtract the 10. So I am going to, now this is where an arrow would be good for. Like you have to send them for a pathway. You know, there's an arrow. See, you can use your arrow. You're going to send them for like a trip. Send them for like a walk. So here we have 2x squared, and then we have 6x minus 5x is 1x minus 10 equals 0. Now, I will always try and do decomp first if I can, so factor it. If I can't factor it, I can go to quadratic formula. Quadratic formula always works, but it gets a little confusing, so I'm going to do decomp first. I know you all practiced it thoroughly. It doesn't matter if you're in 20-1 or 20-2. I know the teachers drilled factoring. You just might not remember it at this current moment. So we're going to go through it. So what do? We say what times what equals, and I always write them out as statements so that I can't mess them up. You could do your X or whatever the heck you use, but I write them out because then I can double check my mathematics. So what multiplies to give me the outside 2 numbers? Okay? So 2 times negative 10. So it's going to multiply to give me negative 20. You see how I just multiplied those outside 2 numbers. We agree? So it's what multiplies to give me the outside and adds to give me the inside. So what plus what equals positive 1. So I need 2 numbers that multiply to give me the outside, and then 2 numbers that add to give me the inside. Same 2 numbers. So I need to multiply to give me the outside 2 numbers, adds to give me the inside number. We agree? Okay, what 2 numbers multiply to give me 20? 1 and 20, 2 and 10, 4 and 5. That's all I can get you 20, correct? Now if I need a negative 20, I'm actually going to have to multiply by one of them being positive and one of them being negative, right? Like negative 1 and 20 gets me negative 20, right? Negative 2 and 10 gets me negative 20. Negative 10 and positive 2 gets me negative 20. So when I need to multiply to get a negative number, one of them has to be positive and one has to be negative, right? Because the positive times the negative gets me a negative number. Okay? So my options were 20 and 1, 10 and 2, 5 and 4. Do any of these, if I put them together, get me 1s? 5 and 4. We agree? So I know I'm going to have a 5 and a 4 in these blanks, because the blanks have to have the same numbers. We agree? What's the catch currently, though? 5 plus 4 is 9, and 5 times 4 is positive 20. Yeah?
One of the numbers has to be negative.
One of the numbers has to be negative. And how do I figure that out? Yeah, negative 4, because it's the addition one that tells you which one needs to be negative, right? So if I made the 5 be negative, I would get negative 20 and then negative 1. Is that good? No, so I'm going to have to make the 4 be negative, because 5 times negative 4 is negative 20. 5 plus negative 4 is positive 1. So that's why I write out the statements, because the statements can double check my mathematics. Yes? Okay. You can't just go x plus 5, x minus 4, because this number is not a 1. You have to do decomposition. Thinking caps. We're using our thinking caps, okay? Everyone's paying attention? Positive 1x can be formed from 5x plus negative 4x. Is that true? 5x plus negative 4x equals positive 1x. Is that not a true statement? Everyone's following along? If you understand decomposition and not memorize steps, you will be in a much better boat. Understanding mathematics makes life way easier. Okay? So I'm going to take this 1x here. Do you see this? I'm going to take this 1x, I'm going to rip it off my board, I'm going to toss it across the room, and I'm going to take 5x minus 4x and put it in its place. Because what is 5x minus 4x? 1x, is it not? Is 5x minus 4x 1x? 5x minus 4x is 1x, yes? So can I take this 1x and replace it with 5x minus 4x? Because that's still 1x. Is that not a true statement? 5x minus 4x is 1x. So that's why the first term and the back term don't change when you do decomposition, because you're not doing anything with them. You're taking this 1x, you're replacing it with the 5x minus 4x. You're replacing it with these. So I'm going to get 2x squared, and I'm going to go minus 4x plus 5x instead. Why am I putting them out of order? The 4 goes better with the 2, and the 5 goes better with the 10. So I just literally took that 1x out and replaced it with negative 4x plus 5x, which is 1x. Do we see what I did? Do you agree? I just took the 1x off the board and replaced it with negative 4x plus 5x because that is 1x. Did I do anything with the 2x squared? No. Did I do anything with the negative 10? No, because I didn't do anything with them. And then in grade 10, you learned how to group, because you learned grouping when there was 4 terms for decomp. So these group and these group. What can I take out of the first two? A 2x. And what am I left with? X minus 2. And then what do I take out of this back bracket? A plus 5. So you put a sign with it. 5x, take out a 5, I'm left with x. Negative 10 divided by 5 is negative 2. Wait a second, they match. They have to match. They have to match. Now people remember it's x minus 2 and 2x plus 5 because I was told that. That's usually what they tell me. Terms are separated by plus signs, yes? So if I look at this term here and I look at this term here, do they have a common human that I can take out of both of them? What can I take out? X minus 2. So that's why you get an x minus 2, because you take an x minus 2 out of both of them. Now if I take an x minus 2 out of 2x, x minus 2 I'm left with 2x. And if I take the x minus 2 out of this one, I'm left with plus 5. That's why you're left with those two. That's why people are like, why don't I get 2x minus 2s? You don't get 2x minus 2s because you're taking an x minus 2 out of both, then what's left over is 2x minus 5 equals 0. Right? And then what we're going to do is we're going to go x minus 2 equals 0. 2x plus, thanks, red pen started writing red, equals, oh, it's back plus. And then we have to solve them. Add 2, x equals 2. This one we're going to subtract 5. 2x equals negative 5. Divide by 2. X equals negative 5 over 2. What do we have to make sure we do? Still write your NPVs. So we're going to get x equals 2, comma negative 5 halves. What were my NPVs? X can't equal negative 2 and negative 3. Were any of my answers negative 2 or negative 3? Were any of my answers negative 2 or negative 3? No, so they're good. So what do you suppose I'm going to give you for homework? Factoring. I'm going to give you factoring for homework. Because what do you need practice with? Factoring. Can everyone get to this point where it's set equal to 0? Yeah, most people can get everything equal to 0. It's the factoring where life goes a little rough. Yeah. You could. Yeah. But quadratic formula sometimes makes it harder. Like it's way more extensive and then people make oopsies. Because there is way more spots to put in numbers, right? So we're gonna cover it with factoring and make sure we can still try and do the factoring. But then we're also gonna go with quadratic formula because there are certain instances where you can't factor and you have to use quadratic formula. But I've seen people make big oopsies using the quadratic formula and get wrong answers. So I used to just focus on the quadratic formula, but what happens if they give a question where like Bob made a mistake and Bob factors? Yeah. So I don't want you to ever go to a diploma question and not be able to get 100% and say, Mrs. Lepp taught us this, I just forget. Like I'm okay. I don't want that to happen, but I don't want you to ever get to a question and be like, girl, we didn't factor. What is this kid doing? This kid is doing that wrong. That's what they're doing wrong. They should have just put it wrong. So I want you to always have all the perspectives so everyone can get 100 if they want to, but they might do not. That's okay. So these are the 5 questions you'll get. Let's set up the questions for you, okay? So everyone is going to stop writing and you're just going to pay attention first. So I need to set up the multiplication and addition statements. So what times what equals what? What number am I going to have to multiply to? Negative 24, because I have to do the 2 times the negative 12 and I have to take the sign with it, right? So what multiplies to give me negative 24? And then what adds to give me what? The 5, right? Okay, let's look at number 2. Let's set this one up. What times what equals what number am I going to multiply to get for this one? 18, because I'm going to go 6, positive 6 times positive 3, right? Which is 18. And then I'm going to do what plus what equals my middle term, which is positive 11. Do you see where I'm pulling the numbers from? Multiplies to give me the outside, adds to give me the middle. And you have to take the signs with it. So what about this one? What times what equals, what number am I going to get? Negative 12, because I'm going to go 2 times negative 6, correct? And I get negative 12. And then I'm going to go what plus what equals 1, that middle term. So you see how I'm getting what multiplies to give me the outsides with the signs and adds to give me the middle with the sign, right? I have to take it with me. So then what about this one? What times what equals, well, this will be 1 times negative 16, which is negative 16. And then what plus what equals what? Negative 6. I have to take that sign with, right? And then what about this one? What times what equals 3 times negative 2. So it multiplies to give me negative 6. And it adds to give, adds to give me negative 5. You see where I got the numbers from? Does that make a little more sense? Multiplies to give me the outside, adds to give me the inside. Even if you're stuck at how to do decomp, try it. But even if you're stuck, at least get the numbers that would work for that. That would multiply to give you that number, add to give you that number. Get to that. Okay? All right. So these 5 questions are due for tomorrow. Make sure you're done them.